Okay, this is part 2 of the system word problems lesson. The next thing we're going to look at is a different kind of word problem. So the first one we looked at was both equations were in slope-intercept form, and we went through and solved that. And then now this one is slightly different, so let's take a look. It says, Sam spent $24.75 to buy 12 flowers for his mother. The bouquet contained roses and daisies. Roses cost $2.50 each, and daisies are $1.75 each. Write a system of equations to represent the situation above, and how many of each type of flower did Sam buy. Okay, so now if you remember again back to our linear function days, when you see two distinct items, then that should be an indication that we are using standard form. And the two items that we have here, I'm actually going to write off to the side. So you can label this however you want with these when you have two distinct items, but I'm going to say X is roses, and we'll say, oops, let's go with maybe a rose color. Here we go. Nope, not roses. These would be daisies, so I guess it doesn't really matter. Okay. All right, so roses and daisies. I guess roses aren't green usually. So, all right. It says Sam spent $24.75 to buy 12 flowers. Okay, so you're going to have one equation that's just going to be about cost. So let's just look at the stuff that says all about cost. So we know he spent a total of $24.75. We know that roses are $2.50 each, and daisies are $1.75. So these are kind of the things that we want to focus on for one of our equations. So I know, okay, let's start. Roses are $2.50. So let me zoom in a little bit here. $2.50. And we said roses, if we look over here, roses were X. Okay? So $2.50X plus daisies are $1.75. And again, notice that daisies are where our Y. Okay? And then our total was $24.75 that he spent. So this is just one equation all about cost. Okay, so now there is another equation here we have to write, and this one's a little sneakier to pull out. It says he bought 12 flowers. Okay, well, we only have two kinds of flowers here, roses and daisies. Well, roses are X. Daisies are Y. So it should make sense that roses plus daisies should give you a total of 12. So there's only one number here. So that is kind of a tricky one to pull out. The other one has a, you can see the cost for each one, so it's a little easier to figure out. But that's it. Now that's your system. Now notice both of these are in standard form. So that's when we want to use elimination. Okay, so that's what we're going to do here. All right, so I have to, let's see. I'm going to need opposites, so I think I'm probably going to, let's get rid of, you could get rid of X or Y. I'm just going to get rid of X. What that would mean is I need to multiply this bottom equation by negative 250. And that would give me a negative 250X. So I'm going to copy the first one. 250X plus $1.75Y equals $24.75. Now the bottom one is going to be negative 250X minus 250Y equals negative 30. Okay, and now I can add these together. So these will eliminate, that's what I want. This is going to give me negative 0.75y. Make sure you watch that negative. And this would be negative 5 25. Okay, so now lastly I need to get rid of that negative 0.75. It's multiplication, so I'm going to divide. Okay, so these cancel, I get y equals, and if you divide those two, you get 7. Okay, so what does that mean? It means he bought 7 roses. Okay, so now let's go back. You can see right here, I'm going to plug into this equation because it's way easier. So you have x plus y is 7. That has to equal 12. All right? So subtract 7 from both sides. 12 minus 7 is 5. So there's... Now I don't want to write my answer as an ordered pair here because it asks for how many of each type of flower did Sam buy. Okay, well let's write it out here. It says x is 5. That represents roses. So we're going to say Sam bought 5 roses and 7 daisies. Okay, and this is my answer right here. Okay, so make sure you answer that question, and when you're doing word problems, it won't be written as an ordered pair. It'll be written out in words, okay? And that's a standard form word problem for systems. All right, hope that makes sense. See ya.